Hello, welcome to lesson 4 of sequence, block 1. I'll share my screen. So, in your previous lesson, you learned how to represent sequence in a tabular form and also in a graphical form. And then you were able to use the tabular form to show whether a sequence was linear or non-linear. So recall that in the tabular form, you check the numbers and saw that for a linear sequence, the difference between each term of the sequence was a constant number. So if you were adding 3 every time, you will notice that it's just 3 you're adding every time. Or if you're subtracting a particular number every time, you'll see that that was the number that was constant. And then for a nonlinear sequence, you saw that the number was the number by which it was changing from one term to the next of the sequence was different. It wasn't constant. And then in a graphical form, you saw that you had a nice straight line that could connect all the points when you plotted the value of the sequence against the position. So in today's lesson, we'll be able to do more learning on top of what we already know, and that is to be able to recognize the difference between linear and non-linear sequences. Okay, but before we move on to the main lesson, I would like you to do a retrieval practice. I'll give you 3 minutes to get this done. Okay, we have 1 minute left. Okay, let's check our answers. So the first one, you were required to write the number of circles used underneath each term of the sequence. Okay, so you should get 14. So that one, you just need to count the circles. So 14, 11, and 8. And then number two, you were asked to draw the next term in the sequence. Okay, remember what we've learned so far from our very first lesson. We count from the left. So this is the first term. This is the second term. This is the third term. Okay, so notice that we're taking away 3 circles every time. So we're taking away 3 circles. So if you take away 3 from 8, you're going to get 5. So the fourth term, yeah, is the next term of the sequence because we're already on the third term here, which is 8. So we're going to have 8 minus 3 should be 5. So we just need to draw 5 circles. Then number 3, you were asked how many circles will be needed for the fifth term. So if we're already on the fourth term, which is 5, if we take away 3, the fifth term will have to be 2. Okay, so the fifth term is 2. So we just draw 2 circles. Okay, and then next we're asked how many terms can you draw using circles? Of course, it's only 5 terms because we can't, we only have 2 circles. We're not going to be able to take away 3 circles from 2 circles. So there's nothing to draw for the sixth term. Okay, let's rub this off before we move on. Okay, let's do some new learning. So remember what we learned in our previous lesson. A linear sequence has a constant difference between each term. Okay, so if you look at this sequence here, that's 2, 5 circles, 8 circles, and 11 circles. So if we check how much these terms of the sequence is changing from one to the next, we see that we adding 3 every time. So that number is constant. That's why we call it constant difference. So the difference between the first term and the second term is 3. Difference between the second term and the third term is 3. Difference between the third term and the fourth term is 3. So we say the sequence is linear. Okay, let's check these. Okay, if we're asked to decide if each of these sequences is linear or non-linear, we have to do the same. So for this one, you see we have 1 square, this one will have 3 square, so on and so forth. So if we write the numbers under, okay, you see that the number by which it is changing from one term of the sequence to the next term of this sequence is not constant, it's not the same. So this sequence is not linear. Okay, have a think about the other two. I'll give you 10 seconds. Okay, so for this one, you can see that to get from 80 to 70, it's 10. We're taking away 10. To get from 70 to 60, it's 10. We're taking away 10. So this is a linear sequence. For this one, to get from 5 to 10, we add 5. But then we're going back to 5 again. So we add 5 and then we take away 5. Okay. Positive 5 and negative 5 are not the same. It's not, the numbers are not constant. So this is not a linear sequence. Okay. All right. I would like you to have some practice. So remember what we've learned so far. You've learned that a linear sequence has a constant difference. So the sequence, the number is changing by the same amount as you move from one term of the sequence to the next term of the sequence. A nonlinear sequence does not have a constant number changing every time, so the numbers will change. Okay, so here are the questions you're going to work on for your practice. You need to do only question 1 to 4. That should take you about um, 6 minutes. There's especially question 3. There's a fair bit of work to do there, especially with the fractions. That may take you a bit of time to figure that out. Okay, we have about 2 minutes left. Okay, let's check our answers. So for the first one, you were required to write, you asked which diagrams show linear sequences. So you only needed to pick the ones that show linear sequences. Now remember, what we said is actually easier to write the numbers of the objects you see of the diagram, to write them on there, and then that way you can check whether the uh, whether the sequence has a constant difference, whether the numbers are changing by the same amount every time. Okay. And then for this one, you were asked to complete it by writing the missing numbers. Okay. So let me zoom in. Let's see what I can zoom in. Okay. Can zoom in now. Um, but here are the answers for you to check what you've done. So here you can clearly see that these are linear sequences. This one is changing by one every time. We're adding one every time. Here you can see that the numbers are changing by the same amount. Here we have 7 circles. Here we have 5. Here we have 3. So we're subtracting 2 every time. Okay, we're taking away 2 circles every time. So this is a linear sequence. These are not linear sequences. Okay, the other one, you were required to complete the numbers by which the terms of the sequence was changing every time. Okay, the sequence is linear as the difference is constant. Here, you notice that the the numbers is not constant, it's not changing. You can see it there. Okay, we added 3, we added 5, and then we added 5. So that's not a constant difference, so it's non-linear. For these ones, the one I want to explain particularly is, I think it's E. Okay, so you can see that we're adding 2/3 every time. Okay, we're adding 2/3. How do we know? To get from 3 to 3/2, you're adding 2/3. To get from 3/2 to 4, you add 1/3. You add another 1/3. That's why you have 4/1. Okay, all right. And then here, Tommy is incorrect. Okay, the sequence is not linear. The difference is not constant. Sometimes the difference is 5 and sometimes the difference is -5. This is an oscillating sequence. Now take note of that word because at some point we're going to use that word in maths. So it's oscillating from one value to the next value to the next value to the next value. Okay. All right. Let's do some new learning. So remember in your previous lesson, we were able to put sequences, represent sequences in tabular form, and we were able to check the numbers Okay, the value. Remember, we call this term value. We call this term value. That is the number of items that you can see in the diagram of the term of the sequence. Okay, so, and we were able to check whether it was linear or non-linear. So this is clearly non-linear because you can see the number is changing. It's not constant. This will definitely be linear. Okay, and then we also were able to put it in a graphical form, and then the graphical form was quite easy to spot because after you've plotted the value of the term against the position, you would see that it was a nice, all the points were lined up and you could just join them with a straight line. But when you plotted the sequence that was non-linear, you would notice that the line was curved. So it's not changing by a constant amount. That's what the line is telling you. So it's a non-linear sequence. So linear, straight line, you can see it on the graph. Non-linear sequence, it's not a straight line. Okay. All right. Time for you to have a go at the rest of the questions. So you did up to question 4. Okay. So you can now answer the rest of the questions. So you can answer question 5 to 8. So I'll give you 5 minutes to get those done. Okay, we have 3 minutes left, guys. Okay, it's time to check our answers. So for this one, you're asked to write a number to either make the sequence linear and here non-linear. So this one, you're asked to check which one is linear and which one is non-linear. So here are the answers. Okay. Question 5. Okay, so any number other than 27. So basically, you just needed to write any number that would just make it not be a constant, not be a constant amount. So it will change by a different amount. Okay, and then here you're just asked to check the tabular form to see whether the sequences they are linear or non-linear. And then for the graph, you can see that one the points are lined up, so you can join them with a nice straight line. You can join this with a straight line, so these are linear. Okay, you by visual inspection, just by looking at it, you could have done it. Okay, and then the last one is the points on the graph, show linear sequences, they form a straight line. The points on the graph showing non-linear sequences do not form a straight line. By now, we should know that. We learned that in our previous lesson. Okay, and this is for questions 7 and 8. So Alex is correct. We only have one difference, so we don't know if there is a constant difference. Okay, remember, constant difference, you need to have at least 3 terms in the sequence. So you see the first constant difference, you see that, okay, it changes by the same amount first time, changes by the same amount second time. All right. We would need 3 terms to know if a sequence was linear or non-linear, as this would give us 2 differences and we could see if they are constant or not. Therefore, it is impossible to tell what type the sequence is. Okay, and then question 8, you can see this is the answer here. Question 8, you were given some questions to do, quite a wordy question. And then this is the answer. All right. So 75,225, and the third term is any number other than 375 if the sequence is 3 terms long only. All right. There is only one answer for part A, as you have to add on the same amount each time. For B, there are an infinite number of answers, as the difference could be any number in part A. The fifth term would be 675. So for part B, there could be any answers for the fifth term if there is a pattern. For example, we're doubling it each time. If the sequence is random, then the fifth term can't be predicted. Okay. All right. That brings us to the end of our lesson. Until next time, bye now.